Hi everybody, this is Dr. Nigro with the Chem Calculations Screencast. This one's going to focus on molality and mole fractions. All right, so these are two of our units that we use to determine the concentration of a solution. All right, so this is going to give us an idea quantitatively of how much solute is dissolved within a particular amount of solvent or within a amount of solution. So this is concentration of solutions. All right. Now, these are going to be different than our molarity. All right. Molarity, if you remember, is moles of solute divided by, liters of solution. All right. These are going to have different values in our numerator and denominator. So we have to make sure that we pay attention to what the formula is telling us. So a different way to express that concentration. All right, molality in particular is useful when we have solutions where they're going to undergo some temperature change because it removes volume. All right, so the molality of a solution is going to be equal to the moles of the solute divided by the kilograms of the solvent. All right, so when I think about my formula here, I use the mole symbol of the solute divided by the kilograms of the solvent. So for those of you who have me in class, I always designate my parts of solutions when I'm working with solutions, and I use a U to represent solute. Get it? I use a V to represent solvent, and then I use an N to represent solution. All right, so don't be surprised if you see me use those when we talk about these different concentration values. All right, so again, molality, moles of solute divided by kilograms of solvent. All right, now the unit here would be moles per kilogram, or just like molarity, we sometimes just use a lowercase kind of italicized m, or you might see the word molal in the problem, just like we use molar for molarity. All right. Now, mole fraction, let's just do it for the solute, is exactly what it sounds like. It's the fraction of the total moles that belongs to the solute. So in this case, the moles of the solute divided by the moles of the solute plus the moles of the solvent. So this would be our total moles. All right. It's the same idea as what we saw when we did Dalton's law of partial pressure, when we dealt with gases. Same idea. Part divided by the whole. All right. We could easily rewrite this from the solvent's perspective, where we'd have the moles of the solvent divided by the moles of the solute plus the moles of the solvent. All right. So again, same as in the gas unit. All right. All right, so let's do a couple calculations. Let's start with number one. So we have a solution that was prepared by dissolving 800 grams of NaOH into 2 liters of water. All right, so I'm going to come over here, and I always set up my little table of stuff so I know what is what. All right, generally speaking, the smaller amount is your solute, the larger amount is the solvent. It's not always true, but most of the time it's a good rule of thumb. So in this case, I have less NaOH, so that's going to be my solute dissolved in a larger amount of water. So that will be my solvent, and the two together, the sum, gives me my solution. All right. So I'm trying to calculate the molality of the solution. So I need to know the moles of the solute. Well, I have grams, so I can take those grams, 800 grams of NaOH, and I can convert those into moles using the molar mass of NaOH. So I get out my calculator and my periodic table, and I find that the molar mass of NaOH is 40. All right, and when I divide 800 by 40, I get around 20 moles of NaOH. All right, so I've got the moles. All right, the other part is kilograms of solvent. So my solvent is H2O. I have 2 liters, right? Now, I know that for every gram, I have 1 milliliter based on the density. So for every liter, I have 2 kilograms. So this is actually 2 kilograms of water. All right, so with that in mind, I can use my molality formula. It's going to be the moles of the solute divided by the kilograms of solvent. Plug in the 20 moles of NaOH. Divide that by the 2 kilograms of water. And I'm going to get a solution that is around 10 molal. Okay? All right, for part B, it says calculate the mole fraction of each component of the solution. All right, well, for mole fraction, I'm going to need the parts and the wholes. I have one of my parts. I've already calculated the moles of NaOH, but I also need the moles of H2O. So I'm going to start with that 2 kilograms, convert that into grams. So 2 grams of H2O. Use my periodic table and calculate the molar mass, which is 18.02 grams per mole. All right, divide 2,000 by that 18.2 grams, and I find I have 111 moles of water. All right, so the mole fraction for my solute, NaOH, is going to be equal to 20 moles divided by the total. So 20 moles plus 111 moles. All right, I do some calculation, and I find that the mole fraction for my solute, NaOH, is 0.153. All right, now I can repeat this for H2O. All right, I just swap out that 20 on top and put 111 because that's the moles of water. And then again, I have my total, which is 20 plus 111. And I find that I have 0.847 in terms of my mole fraction. Now, you should notice, hopefully, that these two mole fractions, 0.847 and 0.153, added together equal 1, and that should always be the case. So if you only have two components, another option would have been to find the mole fraction of one of your two components and then subtracted that value from 1, and that would give you the mole fraction of the other. All right, so that's kind of a shortcut. All right, so let's slide down to this next problem. All right, in this case, your instructor hands you a 0.85 molal solution of sulfuric acid. All right, the solution was prepared with 750 grams of water. How many grams of sulfuric acid must we have used? All right, so again, I'm going to look at the pieces. All right, so I was told solution of H2SO4. So you always list the solute in the name of your solution. So that tells me that my solute is sulfuric acid. All right, it was prepared using water, so that is going to be my solvent, and the two together is going to give me that solution. All right, if I want to find grams of sulfuric acid, I have the mass of the water and the molality of the solution. So I can use those two numbers to find the moles of sulfuric acid, and then once I know the moles of sulfuric acid, I can convert to grams using molar mass. All right, so I'm going to start with my molality formula, moles of my solute divided by kilograms of my solvent, and then I'm going to plug in what I know. So 0.85 molal is going to be equal to my unknown, moles of solute, divided by my kilograms of water. Well, I had 750 grams, so if I divide that by 1,000, I have 0.750 kilograms. I'm going to multiply that to both sides, and the moles of solute is going to equal 0.6375. So that's going to be moles of H2SO4. All right, now I'm just going to use molar mass. So I know that 1 mole of H2SO4 has a mass of 98.09. Thank you, periodic table. Whoops, not H2O. It's very different. SO4. If I do that multiplication, then I'm going to find that I must have added 62.5 grams of my H2SO4 as I prepared this solution. All right, next, mole fraction of each component in the solution. All right, same thing as before. We know the moles of our solute, but we need the moles of our solvent. So we take our 750 grams of H2O, use its molar mass. 1 mole of water has a mass of 18.02 grams. To find the moles of water, which turns out to be 41.6 moles. All right, this is of H2O. Right, then I can set up my mole fraction. I'll do it for the solute, H2SO4. All right, it's going to be 0.6375 moles divided by our total, so 0.6375 moles plus 41.6 moles for the water. All right, do that addition and then division, and I'm going to find that the sulfuric acid has a mole fraction of 0.015. All right, now I'm going to use my shortcut this time. All right, the mole fraction of water is going to be equal to 1 minus the mole fraction of sulfuric acid. All right, so that means the mole fraction of water is going to be equal to 0.985. And so I have both of my mole fractions. Okay? All right, so again, solute, solvent, solution, very important to identify the different parts of the solution. Please do not mix up molality and molarity. It's one letter difference, but the calculation is very different. All right, for molality, we need moles of solute divided by kilograms of solvent. All right, if you're going to do mole fractions, make sure that you have moles of each component, and then you take the part and you divide it by the whole. Okay, hope that helped.